All right, welcome back, everybody. I'm Marshall. This is the third session of the day. I'm going to be going over Burst Buffer Lua, our new Burst Buffer plugin, and also slurmscriptd, which is a new process that we've created to be able to run scripts. So as a reminder, there are 5 presentations. They'll be on our YouTube channel for a couple weeks, and I'll take questions at the end. The chat is moderated by SLUG'21, and they'll be saving your questions and forwarding them on to me. And feel free to ask them throughout the chat, though, throughout the presentation. Okay, so first, let's get into Burst Buffer Lua. So Burst Buffer as a concept is intermediate storage between slow long-term storage and the compute nodes. The idea is when a job needs to access a large amount of data that's on some long-term storage, you want to move that data from that slow storage to some faster storage closer to the compute node so that when the job is actually running on the compute node, it has much better performance when accessing that data. And from Slurm's perspective, ideally you want to do that while the job is pending. That way you don't waste compute time moving data. You really want compute time on the compute nodes to be used for actual computation as much as possible. So what Slurm does with the Burst Buffer Data Warp plugin is Slurm calls Garey's data warp script at certain points in the job's lifecycle. Now, the Garey's data warp script will actually do the interesting work in moving files or directories from point A to point B, and the job will request how that is done using Garey's syntax. Slurm doesn't do any of that interesting work, it just calls Garey's data warp script. So we wanted to create a new Burst Buffer plugin that could be more generic. So that's what we've done, Burst Buffer Lua. It's very similar to the Data Warp plugin. It provides hooks to a script at those same points in the job's lifecycle. The script is called burstbuffer.lua, and it can be written by a system administrator and do anything that the sysadmin would like it to do. So in that sense, Burst Buffer is somewhat of a misnomer because the script doesn't have to move data. It can literally do anything that you think would be useful to do at specific points in a job's lifecycle. And so the asynchronous calls to this script is really the interesting part. So on the left, we have the different job states, and on the right we have different functions in burstbuffer.lua that are called at those points. I'll just let you take a look at that for a moment. This is an incomplete list of functions, and we have the complete list documented on our website. So one obvious use for this plugin is moving data, and one use that some sites are already excited about is using this with cloud nodes. The idea is you don't want to be paying for a cloud node while you're just moving a bunch of data from on-site storage into the cloud. You'd really like to move the data from on-site storage into the cloud before you're paying for the cloud node. So you can do that with this Burst Buffer Lua plugin, move data from on-site storage to cloud while the job is pending. And then once you're done with that, the job can be allocated, the node can be spun up, you can start paying for the node, and the job can do the computation that it needs to do. Or you can do anything that you want. We're very interested to see what you all come up with, what ideas you have for using this new plugin. In order to use it, a job simply needs to have the string #bb_lua in the job script. Now this string bb_lua is configurable. You can change it to something else, but the default is bb_lua. Alternatively, you can use the command line option --bb, and that is available for salloc and srun as well as sbatch. Any additional syntax needs to be defined and enforced in the burstbuffer.lua script. We didn't want to try to anticipate everybody's needs, and so we just wanted to make this generic as possible. So that's why we made that choice. There's a burstbuffer.lua.example file that's distributed with Slurm, and that has all of the functions in the file, and it has documentation about how to use the functions as well. So let me run through an example. First, I have this job script at the top, and it has the #bb_lua there, and that way the job requests for Slurm controlly to use this burst buffer Lua plugin. The rest of the stuff after that, the stage in, source equals, and then the file, destination equals file, that is all going to be parsed by my burstbuffer.lua script, and I'll show that in the following slides. And the bottom half of this slide is just showing running the job and then showing the job output, how the script is moved, how the files are actually moved. So here are some portions of the burstbuffer.lua file. First, this slurmbb job process function is called on job submission. If this function returns an error, the job is rejected. If it returns a success, the job is accepted. And so this function just parses the script, and it can do something like if you don't like what the user put in their job script, then you can just reject the job right then, and you can give a reason for it. I've implemented these data in and data out functions, which are called when the job is pending and when the job is completing. So what those do is they parse the job script to get the source and destination files, and then it calls this function stage file. All that's going to do is copy a file from point A to point B. And so I'm going to show these functions in bold next. So here's how I parse the job script. First, I read the entire job script, and then I call this next function, getStageSourceDest, which parses the lines. And then I just return error or success depending on what I found. And I also return the source and destination files. So here's how I parse the lines with stage in, source equals, destination equals. It's some pretty lazy regex. All I'm looking for is source equals, quotation marks, and then anything without any white space. And destination equals, quotation marks, anything without white space. That's pretty lazy. You can find some actual regex that parses good file paths, and you can do it with directories or however you'd like to do it. This is just a simple demo. I also call slurm.loginfo to show that you can log to the slurm controlly log file, and then I show the different files that I got out from it. So this stage file function, it just copies the source file to the destination file. Really simple. And that's it. Feel free to grab those slides once they're posted, copy it, play around with it. It'll be available. Hopefully that's useful to you. And so burstbuffer.lua, we call it in two different ways. Some of the functions, such as slurmbb job process, are called directly from the slurmcontrolD. Lua can call C directly without having to create a new process and exec that. And that's really quick. So we take advantage of that for this because slurmcontrolD is holding locks during those functions, and they need to run quickly, or else it'll really hurt slurmcontrolD performance. The rest of the functions that are called asynchronously, Slurm forks a new process, specifically slurmcontrolD, or slurmscriptd rather, which we'll get to in a moment. And then that new process will call burstbuffer.lua. By doing it this way, we can easily kill these child processes, such as if they time out or if the job is canceled, or if you shut down the slurmcontrolD. That's all documented, which is called which way. Just make sure that the ones that are called synchronously have to run quickly. Documentation. Okay, slurmscriptd. So the motivation for slurmscriptd, I'll go over that first. The fork call is really slow. So slurmcontrolD calls quite a few different scripts, such as prolog, epilogue, slurmcontrolD, and burst buffer data warp scripts. And in order to call those scripts, it needs to call fork, which duplicates the process memory, creates a copy, and then from the child, it calls exec to actually run the script. And the more memory you have to duplicate, the longer this is going to take. In addition, fork stops all other parallel execution of the calling process, so it's quite slow. Just to show this, I ran this test with prolog and epilogue slurmcontrolD, which are in 2011 were both forked from slurmcontrolD, and so each job would cause slurmcontrolD to fork twice, once for each prolog and epilogue. And so I ran 10,000 jobs, and with slurmcontrolD with very minimal memory, it took almost 5 minutes. But when slurmcontrolD had a 5 GB memory footprint, it took over 18 minutes. Very slow, and the sites that were running burst buffer data warp really saw this because every single data warp call is forked from the slurmcontrolD. So we really wanted to address this with a new burst buffer Lua plugin. So we created a new sort of daemon that runs these scripts and called that slurmscriptd. So how that works is when slurmcontrolD starts up, it immediately calls fork, and then slurmscriptd initializes from that child process. By doing this, we can call fork with minimal memory, and that way slurmscriptd just has that very minimal memory footprint, so that when slurmscriptd then can call fork later on to run a script, it'll be a lot faster. In addition, it means that slurmcontrolD doesn't have to call fork. And then after that point, slurmcontrolD loads the state, which will load all the jobs, accounting, reservations, whatever, which can make it very bloated. Whenever slurmcontrolD wants to run a script then, it just tells slurmscriptd to run the script. Then slurmscriptd runs a script, tells the controller when it's done, and then the controller goes on with its life. In the meantime, the controller can of course, do any other work in parallel that it needs to be doing. For shutdown, the controller, when the controller wants to shut down, it just tells the scripty to shut itself down. And the scripty kills any scripts that are running and then shuts down cleanly. This also happens if the controllee crashes for whatever reason. The scripty will automatically shut itself down and kill any running scripts. That way we're not leaving these scripts leaking on the controller node. So the important things are slurmscriptd initializes and kills itself. Admins don't have to do anything special. And slurmscriptd will run these scripts instead of slurmcontrolld. So just to show how this improves performance, I did the same test. As a reminder, without slurmscriptd in 2011, that test took 18 minutes, 5 seconds. But with slurmscriptd, that test took 4 minutes, 23 seconds, which is even faster than it was with slurmcontrolld with a minimal memory footprint. Big performance wins. We're really happy with that. Currently, the scripty only runs prolog, epilogue, slurmcontrolld, as well as any asynchronous calls to burstbuffer.lua. So the new burstbuffer.lua plugin doesn't suffer from the performance issues that burstbuffer data warp had. In the future, we would like to remove most or all fork calls from slurmcontrolld. Here are a few ideas that we'd like to start with, but we don't have any specific deadlines on that. It's not being sponsored right now. It's just something that we'd like to do, but we can't promise any specific dates for it. Anyway, that's my presentation. I will take all your questions now. All right, first question, Killian. So in that case, the Slurm controller is doing the actual file copy, correct? Synchronous called BBLua. So the idea is we're not, if you implement file copying in those synchronous calls, yes, that's true, and that would be bad. So don't implement file copying in the synchronous calls. Only implement file copying in the asynchronous calls. So good question, Gillian. Kent, what user is doing the copying? It's the Slurm user, since it's being called from the slurmscriptd, which is run as the Slurm user. So security implications, it's run on the controller node. It's called by the slurmscriptd or the slurmcontrolld in the case of those synchronous functions. Just make sure that you are safe with your scripts, and it's the sysadmins that implement this burstbuffer.lua file. Stephanie, is it safe to submit Slurm jobs from the burstbuffer.lua script itself to schedule data copy transfer or data transfers? You could do that. You can do anything you want. Is it safe? I think so. I have demonstrated myself to satisfy my own curiosity running an scontrol command from burstbuffer.lua. It did work. I wasn't sure why it would be useful, but anyway, yeah, you can do it. Bjorn, does the burstbuffer plugin have any way to tell slurmcontrolld that the copy in of data is done so that it can schedule the jobs? So basically while the copy in is happening, slurmscriptd knows that's going on. And once that call to burst buffer Lua is done, then slurmscriptd will tell slurmscriptd that it's done with that, and then slurmscriptd says, okay, you're done staging in now. Now that you're done staging in, I can allocate you to some nodes. So it just does that automatically. David, would using burst buffer Lua as a sort of mail prog replacement be a good idea? Our users really like informative emails. Sure. Yeah, mail prog is slow right now since it's forked from slurmscriptd. Yeah, you can do that. All right, any other questions? That's the end of my current list. All right, Teddy. What if a user badly uses burst buffer Lua and uses synchronized calls? So is there any failsafe implemented to slurmscriptd from crashing while transferring large amount of data? So a user doesn't implement the burstbuffer.lua script. The sysadmin implements burstbuffer.lua. So the sysadmin is in charge of making those synchronized calls quick. One issue that I could potentially see is if you're reading the entire job script all at once. If the job script is large, that could be kind of slow. Just be careful with how you implement it as the sysadmin. But a user should not be able to do anything bad with burstbuffer.lua because the user doesn't have any control over that script. Note, he said 20. Killian, does anything to be done to enable slurmscriptd in 2011? Slurmscriptd in 2011 doesn't exist. It's a 2108 thing only. And in 2108, you don't need to do anything to configure it. It just happens. Magically, it starts up by itself. We didn't want to add any extra load to sysadmins there. Brian, copies are run via slurmscriptd on the controller node. I'd rather file copies not happen on the controller node. Would there be thoughts on shipping it off to another node? I mean, there's nothing stopping you from so burstbuffer.lua runs on the controller node, but there's nothing stopping you from inside burstbuffer.lua sending some message to another node and telling that other node to do copies. We don't have any plans to move burstbuffer.lua from the controller node at this time, though. So that's it on time. Oh, never mind. 2 more questions. We'll get through those. Sean, so this runs from the perspective of the controller, right? Any file systems referenced in the staging need to be visible from the controller, not just the login or worker node? Correct. Yes, that's correct. Runs from the controller. Sam, is there a timeout associated with the copy and process? In other words, would really big files trigger a timeout and the job fail to be scheduled? That's configurable in burstbuffer.conf. And you can say no timeouts as well, although there is actually a maximum time limit of something like 28 days. It's rather large. And that's just due to data type sizes, limitations in that. 4 billion seconds or something. 2 billion seconds maybe. All right, and that's it. Yeah, we're going to wrap up now. We're out of time. Thanks everyone, you had great questions. Next session is Nick, Slurm in the Clouds, starts at 11 a.m. Mountain Daylight Time on a separate stream. Thank you.